We've got the perpendicular bisectors. Yes. Monday and Tuesday. Yeah. So the perpendicular bisector and angle bisectors we did on Monday, and then the median and the altitude we did on Tuesday. So what we have is the perpendicular bisector. Bisector cuts the side in half and it hits at the 90-degree angle. Okay. And when they have all three of them, they intersect at the circumcenter, which is this point right here. So I have the three perpendicular bisectors. They're intersecting at the circumcenter, and each of the distances from that point to the point, the corners, the vertices, these are the same length. And not the side, not from the point to the side, but from the point to the vertex. Those are all the same length. And then you get the angle bisector, which has no relationship to the sides, but it cuts the angle in half. So we don't know anything about the lengths of the sides once that happens, whereas here we don't know anything about the angle, just the sides. The angle bisectors intersect at the incenter. And that point is equally distant to the sides. So if you have perpendicular bisectors, you're equally distant to the corners of the triangle. If you have an angle bisector, you're equally distant to the sides. So it's kind of like opposites, right? This cuts the angle in half, so it's equally distant to the sides. This cuts the side in half, so it's equally distant to the angles. Do you see how that kind of works, where they're backwards of each other? Okay, then you have a median, which is kind of a bisector. It bisects the side, but instead of being a perpendicular, it's any angle at all. And it goes to the vertex. And we don't know anything about how it divides up the angle. We only know how it divides up the sides. It divides the sides in half. They meet at the centroid, and then the centroid is this 2/3 thing. So this length from the vertex to the point is twice as long as from the point to the side. Okay, so if this little piece right here is 1, this piece would be 2. Okay, or if the long piece here was 6, this short piece would be 3. The part from the point, the vertex to the point is 2 times the point to the side. Okay. And then you have altitudes, and altitudes go from a vertex perpendicular to the side. This is the height of the triangle. And depending on how you rotate the triangle, there's 3 heights. And they meet at the orthocenter, and there's absolutely nothing special about it whatsoever. It doesn't do, like these all do something where you have side relationships or part relate, this, nothing. Just altitudes meet in the orthocenter, and that's all we can say about that. Like, okay, whatever. Don't do anything with it. Okay. And the difference between an altitude and a perpendicular bisector is they're both perpendicular, but the bisector cuts the side in half, and an altitude may not even hit the next side. It's just going to be perpendicular to the side. So if you have like that obtuse triangle, like that, the altitude will actually be outside of the triangle because it has to be 90 degrees to the opposite side, and like I can't do 90 degrees going this direction, so it may not even ever touch the actual other side of the triangle. So it doesn't do anything special to the sides or anything like that. It just tells me that this triangle is whatever that length is tall from this direction. And if I measured it like this way, it would be that tall. Or if I measured it, well, however this would work out, it would be that tall. Okay, does that help clear kind of things up to have the whole chart together like that a little bit? The note, okay, so you have the definition of inequality. So the definition of inequality is that for any real numbers a and b, a is greater than b if and only if there exists a real number c such that a is equal to b plus c. Okay, so basically it's saying a is only bigger than b if you can add 2 numbers together and it equals a. But we know what greater than means already. We don't really need the formal definition. 10 is greater than 3, right? You didn't know that 10? Okay, well then in that case, want to trade me 10 for $3? I'm just saying.
I'm on a different then.
Oh, okay, yeah. So we already know what an inequality means. We just wanted to give you the formal definition of it. Okay, so inequality, one thing is bigger than the other. We have a new property. It's called the comparison property. We haven't known the name of this before, but we've done comparisons before with numbers, right? We've compared them to see if they were greater than, less than, or equal. Even if you didn't do it in math class, you've done it in the real world, money and things like that, comparing prices. So the comparison property tells you a number is going to be greater than another number, equal to another number, or less than another number. Just we're comparing. So it'll be one of those three things. It can't be anything else. And then these properties we've had before with equality and also with congruence. And so they're the same as they were before. Okay, so we have the transitive property for both greater than and less than. And so it says that if A is greater than B and B is greater than C, that means A is greater than C. So if I put a number in here, 5 is greater than 3 and 3 is greater than 2, then 5 is also greater than 2. And you know it's transitive property because we have this B and B. If you have that in the middle, it's the transitive property. That's the signal for transitive property. And that is if these are equal signs or congruent signs or greater than or less than signs, anything like that. If you get this part right here in the middle that comes out, you have transitive property. And it's the same for greater than as it is for less than. If A is less than B and B is less than C, then A is less than C. So 2 is less than 10 and 10 is less than 15. So 2 is less than 15. It's logical. If you think about it, like the pathway is logical.
Like the properties?
And then we have both. Again, for the addition property, there's 2 also. If A is greater than B, then A plus C is greater than B plus C. Or I have if A is less than B. Basically, same thing as with an equal sign. I can add the same number to both sides and it doesn't change anything. If they were equal, they'll still be equal. If one was less than the other, they'll still be less than the other. If they're greater than, it'll still be greater than. It doesn't change the truth if you add the same thing to both sides. Which is also true for subtraction. I can subtract the same thing from both sides and it won't change the truth. So as long as I'm doing the same thing to both sides with these, the truth is still the truth. Now you'll notice I'm not doing multiplication or division. With an equal sign, multiplication and division work. But with a less than or greater than, that's not necessarily true anymore because if I throw negatives in there, it will change the truth. So I can't use them. So it's just adding and subtracting where that's still true. Just a reminder. Okay, and I'm going to change the names of these because it's annoying that they're not the same letter. So we're just going to call these the letter that they're with. So we'll call this one B and this one A and this one C, okay? Makes more sense. So if you remember the exterior angle sum, the measure of angle D is equal to the measure of angle B plus the measure of angle A. So the outside angle is equal to the 2 angles on the opposite side of the triangle added together. Okay. Now this property gives us this theorem, which tells us this. That's the word either, but it looks terrible, so I'm going to rewrite it. Okay, so let's change these again also. Okay, so what this is telling us is that angle D is greater than angle A, and angle D is greater than angle B. Okay, so basically what we have is, if you have an outside angle and the two inside angles add up to equal that outside angle, that means the two inside angles each have to be smaller than the outside angle. I mean, it kind of makes sense, right? If you thought of it in terms of money, and the outside angle is $1, and the two inside angles add up to $1, so maybe one's 75 cents and the other one's a quarter, they have to be smaller than the thing they add up to make, right? Okay. So that's just what this is that these angles are going to each be smaller than this outside angle. List all of the angles that meet the following conditions. So measures less than angle 7. So here's angle 7, and we want every angle that's less than angle 7. So we need to look at the fact that there are two triangles here. We have this little triangle that angle 7 is exterior to. Actually, let me do a better job of highlighting that. Hold on. I want to be inside only. So we've got the green triangle that angle 7. To do the whole. Okay, and then angle 7 is also exterior to the big triangle. Do you see that? So we've got two triangles, the small green one and the big yellow one that 7 is an exterior angle to. Okay, now this little triangle up here, angle 7 is not attached to, so they don't have a relationship. So it's only the full big or the green that's right next to it. So it's larger than angle 5 and angle 4. Oops, wrong pen. That's from the green triangle. Okay, and then for the yellow triangle, our remote angles are angles 1, and then this angle together. So I'm just going to call that angle 2 plus 4. Because, right, it's both of them together that make up that angle for the yellow angle, or the yellow triangle. If you wanted to be really technical, you could call that JKL, using the letters JKL. So either one of those would be acceptable answers for that angle. Okay, now measures greater than angle 6. Angle 6 is right here. So we have this exterior angle 3 is exterior to the green triangle. So angle 3 would be greater. Angle 2 is not an exterior angle because exterior angles only occur when the side continues, and so this side would have to be continuing out, and it does not make, or this side here would have to continue out, so it's not angle 2. But then if we look at the yellow triangle, angle 6 is also in the corner of the big yellow triangle, and angle 8 is an exterior angle for the big yellow triangle, so we have both angle 3 and angle 8 that would be greater than angle 6. Now, other angles could be greater than angle 6. We just don't know that for sure because we don't have measures. The only ones we know for sure are those two externals. We have two triangles here as well. I have the small yellow triangle and a big giant green triangle. Okay, so 2 and 1 are external to the big green triangle. And for the yellow triangle, the only external angle would be this combination of these two, 2 and 3, would extend out from 4. So let's look at the problems that were given here. Measuring less than angle 1. So angle 1 is external to the green triangle. And so I want to go to the opposite corners and have 3 plus 4 together. Or we could call that angle PQR. And then on this end, I have 5 and 6 together, or PRQ. Both of those would be acceptable, so you can use just the numbers or you can use the letters. And then measuring greater than angle 8 is an internal angle to the green triangle. So we want to go outside of the green triangle. Well, angle 1 won't work because that's right next to it. It has to be on the opposite side. So we get angle 2. And that's the only one we can say for sure. We've got these. Now I want to just go over this real quickly. So if we figure out how many triangles we have here, let me use the highlighter again. We've got green triangle, a yellow triangle, a blue triangle, and a red triangle. So there's 4 different triangles going on here. Okay. And then we have angles that are not labeled here and here. So we won't be able to use those unless we label them. We could call them something if we want to. We can call that one angle pi. And what do you guys want to call this one here? Nothing? Okay, this one will be angle smiley. All right, so so you can see we have 4 triangles. Measures less than angle 1. Angle 1 is external to both the red triangle and the green triangle. So we have to look at both of those.
So why not the other ones?
Because it doesn't actually touch those two. It's directly touching the green and directly touching the red, the whole thing, but see how it doesn't directly touch yellow?
Yeah.
So we can't count yellow or blue because it's not exactly touching them. Okay, so we look at the red first, and I want to go to the other 2 corners of the red, and we've got this angle that makes up this corner, and it's all 4 or all 3 of those. So I'm going to put 2 plus 4 plus 7 because it's that whole thing. And then on this corner we have this angle, which is 8.
But I thought you said we couldn't use the blue one.
No, we're in the red. We're in the far corner of the red. Do you see how that angle is also the corner of the red? It's both the red and the blue. So we're in the far corner of the red for that. And then in the green triangle, we've got angle 2 and angle 3 that are on the opposite side. So angle 2 and angle 3. So let's look at 9. 9 is this side of the red triangle. So I want to go to the opposite 2 corners of the red triangle. So I get this corner again, and this corner here, which we are now calling pi. So I have angle 2, 4, and 7 together, and angle pi. Yeah.
Why do you call angle pi?
It wasn't labeled, so I just labeled it something, and this one I decided was pi, and this one is smiley.
Okay.
So we have angle pi and we have angle smiley. You know why it's angle pi and smiley? Because pi makes me happy. In both versions, the number and the food. Okay. Now, if we look at angle 9, it's also outside of the blue triangle.
So it's 7 and 6?
Yes. Okay. Not too. We want greater than angle 5. So angle 5 is in this small yellow triangle. Oh my gosh, we have an extra triangle that I didn't even think of. Angle 5 is in the small yellow triangle, but it's also in the orange triangle that's made up of the two put together. Do you see that?
And then you can put the other two together too, right?
Yep, I can do all kinds of things. So angle 5, if you're looking at the little yellow triangle, angle 3 is the outside angle. But if we're looking at the orange triangle, angle 1 is the outside angle.
You're not going to do this to us on a test. 6 triangles, right?
Oh no, I'm going to do like 20 or 30.
All right.
Yeah. No.
So outside angle is the 3, and then
3 is outside of the yellow. Do you see that? Yellow. And then 1 is outside of the orange. Which now that we have an orange triangle, I could actually add some up here for number 1 too. Because see, I could be outside of the orange, which would give me 2 and 4 and 5. So then we could get all kinds of crazy on this, but we'll just stick with where we are.
so how come you have for the first one angle 2 plus 4 plus
Because we were in the red triangle, and angle 1 is outside the red triangle, and 2, 4, and 7 make up that corner. You see that? Okay, greater than angle 8. Angle 8 is here in the blue. So angle 5 is outside the blue, and that's an external angle. And I suppose we could make a purple triangle here. I'm covering up all of my things, but angle 3 would be external to the purple triangle. So we've been talking about inequalities, and now we have inequalities that are angle side inequalities. And what we get is the longest side of the triangle is here, correct? And here is the largest angle. And they're across from each other. And then if we come over here, I get the shortest side. And here is the smallest angle. And they're across from each other. That makes like this side over here is like the medium side. It would be across from the medium angle. So we can tell which sides are biggest and which angles are biggest based on each other. And that gives us our theorems. Okay, we get 2 theorems from this. If one side of a triangle is greater than another. So if we look at this triangle, we have that PN is greater than PM, right? 8 is greater than 6. And then that tells me that the sides across from those, so angle M is across from the 8, and angle N is across from the 6, so that means angle M is going to be greater than angle N. And then the other one goes the opposite direction. That tells me if the angles are greater, so angle P is greater than angle M. That means that this side, this is across, MN is going to be greater than PN. So you look at the greater angle is going to be across from the greater side. And we can use this to figure out which sides are longer or which angles are bigger. If we know side lengths, we can find angle relationships. If we know angles, we can find side relationships. So we can use that to list the angles from smallest to largest. So if we look at this, the smallest side is PR. So angle Q is across from, so angle Q is the smallest, and then angle P, and then angle R. 3.7 is the smallest, that's across from angle B.
And then 4.8.
It's across from angle C, and then angle A. So, with the sides, but first I need to find the missing angle. So I take that 180 that the triangle is, and I subtract 45, and I subtract 56. So that's going to be 180 minus 101. No. Yeah, 101. So 79 degrees here. So 45 is the smallest angle, which makes FH the smallest side.
I don't get what you just did.
I found the missing angle.
Yeah, but you subtracted 45.
I added 45 and 56 together to get 101. So I did 180 minus 101.
Oh, okay.
Yeah. And then 56 is next, so that makes FG. And then GH. Here, this is 90. So that makes 90 left. So I do 90 minus 51, and I get 40. Sorry, 39, not 49.
Why do you subtract?
To find this angle here.
Yeah, but I thought you were supposed to.
I know this is already 90, right? So 180 minus 90 gives me 90. So I did the 90 that's left minus the 51. Make sense?
So even if you do 180 minus 90 minus 51,
You'll get the same. Yeah, exactly. And so 39 is the smallest. That makes WY the smallest side, followed by XY, followed by WX. Everybody understood that one? Right, because this is 90. If we list the angles and sides from smallest to largest, why don't you guys go ahead and try that, and then we'll go over them together.